Mini Lesson 3E, Characteristics of Rationals. F of x equals 6 parentheses x plus 2 times x minus 2 all over 2 times x plus 2 times x plus 1. The first thing we want to do is factor. They are already factored. The next step is to find the wholes. It is what cancels out. The x plus 2's cancel out, and 6 divided by 2 is 3. Let's rewrite our simplified rational expression. 3 parentheses x minus 2 over x plus 1. To find the coordinate for the whole, we're going to set what canceled equal to 0 to find the x coordinate. X equals -2. To get the y coordinate, we use the simplified expression and plug in 2 for x to evaluate. 3 times -2 minus 2 all over -2 plus 1. 3 times -4 over -1. That's going to give you a positive 12. The whole for this example is -2, 12. For the vertical asymptote, we're going to take the simplified expression and we're going to set the denominator equal to 0. For the rest of the example, we're going to use this expression instead of the original. X equals -1. That's the vertical asymptote. Using the vertical asymptotes and the wholes, we could determine what the domain is. The domain is going to be all real numbers except x can't equal -2 and x can't equal -1. To write this in interval notation, it would look like this. Negative infinity, comma, -2, parentheses, union, parentheses, -2, comma, -1, union, parentheses, -1, comma, infinity. To get the horizontal asymptote, we'll take the rational expression and find the leading coefficients of the numerator and the denominator. 3x over 1x. They have the same degree, so we're going to divide those leading coefficients. 3 divided by 1 is 3. F of x equals 3 would be the horizontal asymptote. You could also say this is the end behavior for this rational function. For the x-intercept, we are going to set the numerator of the simplified rational expression equal to 0. X equals 2. Your x-intercept is going to be 2, comma, 0. You set the y value equal to 0 and solve for the x. For the y-intercept, we're going to plug in 0 for x and evaluate. 3 times 0 minus 2 over 0 plus 1. 3 times -2 divided by 1 is equal to -6. 0, comma, -6 is your y-intercept. The next example, we have f of x equals 8 parentheses x minus 2 times x plus 2 all over 2 parentheses x minus 2 times x minus 1 times x plus 1. To find the whole, we see what cancels out. The x minus 2's and the 8 divided by 2 is 4. We can write out our new simplified expression to get 4 parentheses x plus 2 all over x minus 1 times x plus 1. Set what we canceled out equal to 0. X equals 2. That's the x coordinate of the whole. To find the y coordinate, plug in 2 into your simplified rational expression. 4 times 2 plus 2 over 2 minus 1 times 2 plus 1. 4 times 4 over 1 times 3. That gives you 16 over 3. The y-coordinate of this whole is a fraction, 16 over 3. For the vertical asymptote, set the remaining part of the denominator equal to 0. X minus 1 times x plus 1 equals 0. Let's use the zero product property. Set each factor equal to 0 separately. X equals 1 or x equals negative 1. X equals plus or minus 1. For the domain, it's going to be all real numbers except x can't equal negative 1, positive 1, or positive 2. In interval notation, it would be written like this. Negative infinity, comma, negative 1, union, negative 1, comma, 1, union, 1, comma, 2, union, 2, comma, infinity. For the horizontal asymptote, find the leading terms of each. We have 4x over x squared. These do not have the same degree. The numerator has a smaller degree. Let's put plus 0x squared at the top. Now they have the same exponent. 0 divided by 1 equals 0. You have a horizontal asymptote at f of x equals 0. For the x-intercept, set the expression equal to 0 and solve for x using the numerator. 4 parentheses x plus 2 equals 0. Divide by 4. X plus 2 equals 0. Subtract 2. X equals negative 2. Your x-intercept is negative 2 comma 0. For your y-intercept, plug in 0 for x and evaluate the expression. 4 parentheses 0 plus 2 over 0 minus 1 times 0 plus 1. It gives you 4 times 2 all over negative 1 times 1. That'll give you negative 8. Your y-intercept is 0 comma negative 8. Summarize how to algebraically find each of these characteristics. To find the whole, you want to factor if you haven't already. And then the factors that cancel, you're going to set that equal to 0. And that's to solve for the x coordinate. Plug the answer in to the simplified expression to find the y-coordinate. For the vertical asymptote, set the denominator equal to 0. For the domain, it's all real numbers except for the x values of the whole and the vertical asymptotes. For the horizontal asymptotes, you want to divide the leading coefficients. The degrees must be the same. If they're not, you need to put 0x to that power on either the numerator or the denominator. If you do that to the denominator, it would not have a horizontal asymptote. For the x-intercept, set the numerator equal to 0. For the y-intercept, let x equal 0 and evaluate. All of the characteristics after finding the whole will be using the simplified rational expression. And before you start anything, make sure you factor. Find the oblique asymptote. You'll do this using synthetic division. X squared minus 13x plus 31 all over x minus 6. 6 will go into the box. We want to set the denominator equal to 0 to solve for what goes in the box. At the top, we're going to write the coefficients of the numerator. 1, negative 13, and 31. Bring down the first number, bring down that 1. To get this number, it's going to be 1 times the number in the box. 1 times 6 is 6. Combine these, negative 13 plus 6 is going to be negative 7. Negative 7 times 6 is negative 42. And then we get a remainder of negative 11. That is a constant. And it is the one's x's coefficient. Your leading coefficient will always be 1 degree less than what you started with when you're using synthetic division. You will have an oblique asymptote if the remainder is not 0. Our oblique asymptote would be the equation y equals 1x minus 7. Simplify completely Then identify the characteristics. We're going to use synthetic division again. 7x squared minus 18x plus 8 all over x minus 2. The 0 in the denominator is 2. That's the number in the box. At the top, we're going to put 7, negative 18, and 8. Bring down the 7. 7 times the number in the box, 7 times 2 is 14. Combine these, we get negative 4. Negative 4 times 2 is negative 8. We have a remainder of 0. That means we do not have an oblique asymptote here. Seven x minus 4 would be the quotient of this. But that will mean that we're going to have a hole. We can rewrite this as parentheses 7x minus 4 times x minus 2 over x minus 2. The x minus 2's cancel out. So we're going to have a hole where x equals 2. Plug in 2 into the x on your simplified rational expression. 14 minus 4 equals 10. We have a hole at 2, 10. To get the x-intercept, set the numerator equal to 0. Add 4, divide by 7, x equals 4/7. In your own words, go ahead and describe the process for using synthetic division here. One more thing I'll add that you could add to your box is, for example, if you had something like this, x cubed plus 5x plus 9, you would want to set that equal to x cubed plus 0x squared plus 5x plus 9. The 0 would go into that row where you put the coefficients of the numerator. Let's look at this last page. The function this is an odd rational. We have a hole right here at 1, 2, 3, negative 3, and then 1, 2, negative 2. We have a hole at negative 3, comma, negative 2. We have a vertical asymptote at x equals negative 2. The domain is all real numbers except x can't equal negative 3 nor negative 2. In interval notation, we could put this as negative infinity, comma, negative 3, union, negative 3, comma, negative 2, union, negative 2 to infinity. If we wrote this in inequality notation, it would look like this. X is less than negative 3, or negative 3 is less than x is less than negative 2, or x is greater than negative 2. For the horizontal asymptote, we have y equals negative 1. For this one, we could clearly see what the range is. It's all real numbers except y cannot equal negative 2 nor negative 1. It's from these values. In interval notation, it would look like this. Negative infinity, comma, negative 2, union, negative 2, comma, negative 1, union, negative 1, comma, infinity. The x-intercept is right here. Looks like it's about -1 and then 0. The y-intercept looks like it's halfway between 0 and -1. So let's approximate that at -1/2. Let's look at the other graph on this page. This type is an even rational. We have a hole right here at -2, 3. We have a vertical asymptote at x equals -1. The domain is all real numbers except x cannot equal -2 nor -1. We have a horizontal asymptote at y equals 4. The range will be everything beneath 4 except for 3. We write that as -infinity, comma, 3, union 3, comma, 4. For x-intercepts, we have 2 of them. Let's approximate those. We'll say -1/2, 0, and looks like 1.5, -1.5, comma, 0. And for the y-intercept, we have 0, comma, 1, 2, 3, 3. What are the differences between odd and even rational functions? Compare and contrast these two graphs and what you found for them. Write that in the box.